population and sample, okay? When we talk about population and sample, we are looking at the entire piece, okay? That's when we talk about the population. So you're looking at the entire set of subjects in which there's an interest. So for example, the population can be all of those students, right? Population could be all adults, okay? Population can be anything, basically. You're looking at the big picture. Okay, the sample is a piece of that, or a part of the population. So if our population was all of those students, a sample might be the juniors. A sample might be Warner House. A sample might be this class. Okay, it's only a piece of the population. Okay, the reason we sample is to make an inference about the population. It is very difficult to pinpoint every person in the population. How many of you have heard of the census before? A few of you, right? How often does it run? Brian? 10 years, okay? 10 years, okay? It's run every 10 years because it's very expensive, okay? Yeah, they're trying to gather data about how many people in the world, right? So you get mailings, phone calls, constant phone calls. You have knocks on your door. They try everything, huh? You've seen that. So they go to find out just a ton of data about the population, right? See if the population increase, decrease. However, there's problems with that. Okay, there's problems with the census. They don't reach everybody. People could lie. The way the questions are asked, blah, 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 blah. That is all the issues with trying to gather information about the population. All right, that's why we sample. God bless you. All right, so for example, the probability and statistics class is doing a study on how many hours students at Ludlow spend on TikTok during one day. They poll one class of each grade and collect their data. So, what would be big picture population? What would it be? Students at Ludlow. Students at Ludlow. And then, what would the sample be? Okay. So very straightforward. Population, big picture, sample is a piece. So now the second is your wrestling coach wants to sign up his team for a tournament over the weekend, first weekend in March. He polls the seniors to see if they are available before asking the whole team. So, what would be the population? Well, the whole team, right? Wrestling team. What would be the sample? Seniors, good. Okay, so we just figured out the who we want to collect data on. Now we want to know what do we want to learn, okay? So that's where measuring comes in, okay? So two keywords is parameter and statistic, okay? So population summary measures are called population parameter. So parameters infer about the population. They measure what you want to know about the population, okay? Then you have statistics, which measure is a result of the sample, whatever you want to measure, okay? So some examples include the average time to run a mile, proportion, percent. Those are some keywords that you will see for parameter and statistic, okay? So if you turn the page, it's hard to measure the whole population like we talked about. So most of the time we do not have a specific numerical value for a parameter. I'm going to show you examples that will have one, will not have one, and you have to figure it out, okay? The parameter might be an expression for what we're measuring. So percent of people that, average time, that, total proportion of. So those are some keywords you will use. Then the sample, when we gather a statistic, that will match. It will actually be a numerical value. So if we say a percent people, the statistic will actually have the percent of what you're measuring. If we say average time for the parameter, the statistic will say average of blah, blah, blah. Okay? So in this example, very, very reliable source, Snapple.com. Okay, as you can see, my little caps over there. 13% of adults in the U.S. are left-handed. At a school's admin conference, 16% of adults attending were left-handed. So in this scenario, okay, the population is all adults in the U.S. The sample were adults at a school's admin conference. So again, keywords are the same, okay? Population as a whole is all, sample is just a piece. Then if you look at the parameter, 13% of adults in the U.S. are left-handed. In this case, we are given a parameter, okay, which is not always the case. If we were not given this, we would write it as the percent of all adults are left-handed. It's the unknown. We don't know what that is. The statistic matches it, okay? If we're given percent here, it's also going to be mentioned in the statistic, okay? So what it looks like when it's an unknown, okay? A random sample of 300 Ludlow juniors were asked when they went to bed during the school week. 85% of these students went to bed after 11, okay? So what is the population? Josh? All Ludlow juniors. Okay. What is the sample? Yeah. The sample. What would be, how many students were sampled? Yep. 300. Okay. 300 Ludlow juniors was the sample. Now, what is given to us? Yep. The percent of what students? Okay. Yeah. Matt? The sample. Okay. So they found out that out of the sample, 85% of these students went to bed after 11. So that is the statistic. Okay. So 85% of the random sample, and you could, instead of random sample, you could put 300 juniors. Okay, so 85% of the random sample went to bed after 11 p.m. You could rewrite or not include random sample and replace it with 300 juniors, or 85% of the sample went to bed after 11. Okay, so since the parameter is unknown, okay, we have to rephrase this to make a general statement. So the parameter would be the percent of all juniors that went to bed after 11 p.m. So, all juniors, yep. So, is the wording similar? Very, right? The only thing we do not know is the actual percent of the whole population. So, the percent of all juniors, we have the percent, which matches the 85, right? Then, instead of we have all juniors, okay? We could have replaced random sample with 300 juniors to match even more. But this shows that you should have the same word, okay? So if you're given a percent and you're not given a parameter, you then replace it the percent of, okay? Let's try another example. Okay. Miss Betta wants to know if any students miss her during quarantine. She polls one of her classes and asks them if they miss her. 74% say that they do. Okay. Yeah, should be higher.
You actually do a poll?
I don't. Okay, the population. What would the population be? Alina? In general, all Mrs. Betta's classes or students. Here they're talking about classes or students in general. So you could say classes or students. Okay. What is the sample? Sample, sample, sample. Yeah. Yep. Okay. What is the statistic? Mm-hmm. Or say that they do. Again, it's very broad, but it's all the same. You can make it as specific as you want or as broad as you want. So some people might put, like for the statistic, just 74%. Okay, great. What does that measure? So that means your parameter needs to be dead on. Okay, needs to have more explanation. Okay, so the parameter would be what?
The ones that you 26%.
Yeah. Perfect. The percent okay. Liv, were you going to say the same thing? Okay. Now, all we're doing is reiterating what we found. Okay. We found out that 74% said they do, right? But to rewrite the parameter, well, what are we actually measuring? Well, it's right there. Okay. The percent of all students or class or all of my classes that miss me. Okay. So we are just reiterating what we want to know. In this case, we're not given a numerical value. Sometimes you will be, like the next one we're going to see. So it's all very similar. That's why it gets very confusing. Yeah. No, no. You won't have to solve, and that's a great question. So there's no math being done here. There's not. There's not. Okay? There's no math being done. The next part of this lesson, there will be. But there's no math being done. Huh? No. Nope. All right, try number 2. Go ahead. Try number 2.
Margin of error is the next thing, isn't it?
Very simple. So what is the, it's all right, we're all going to do it together, okay? What is the sample? M? 3. Three friends. What is the population? Group of friends. Okay, now, Josh pointed it out. Parameter and statistic are given. Okay? Parameter and statistic are given. What's the first thing we know? Yeah.
The parameter is 43 ounces.
You could literally, okay? 43 ounces of day, water was consumed.
I just don't get like what the parameter for
It's yeah, that's what it is.
S and P and P. Population will follow parameter. Sample will follow statistic. So you know there's three friends in sample. You know that the three friends ranked for 38 is this. I thought it was.
Okay, so 43 ounces of water is consumed per day. That was based off of the group of friends, right? Which is our population. It was actually given. If it wasn't given to us, we would say the average amount of water that was consumed per day. Okay? The statistic is 38 ounces of water was consumed per day. Okay? So, you could, here they both were given to you. The statistic represents the three friends, which were the sample. Okay? So, anytime you're talking about the parameter, typically you were not given it. Okay? In this case, you were. But if you were not given the 43 ounces, you would replace it with the average amount of water that was consumed per day. That's what you want to find out about. The statistic is inferring about the population. Okay? The statistic is trying to answer that question. Okay? So that's what it means. So the next thing is the margin of error. We have seen this in polling, okay? We have seen this in any voting situation. The margin of error is the likely error when data from a sample are used to estimate a population characteristic. Okay? So the margin of error tells us how close to our estimate or a statistic we can. Okay? So, yes. Can we just finish, please? The sample size, n, can be used to calculate the estimate of the margin of error. So, the formula, the quick method, is plus or minus 1 over the square root of the sample size. Okay? One thing to keep in mind, the margin of error can be a percent. In some other cases, we're going to look at just a score value. Okay? The larger the sample size, the smaller the margin of error. Okay? This is what we want. The larger the sample size, the smaller margin of error. Because if we have a large sample size, the margin of error is small. That means we're really close to our estimate. The smaller the sample size, larger the margin of error. So anytime after we figure out the margin of error and we're given a statistic, we create a confidence interval. Okay? A confidence interval is our statistic plus or minus our margin of error. Okay? From that, we use to find a confidence statement. You might have seen this on polling, okay, on the news, whatever it is. They say we are 95% confident that between blah, 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 that will occur. So what happens is they give you a range, okay? The margin of error acts as like a buffer to give you a realistic range, not an exact percent. The range calls for any sampling errors that can occur, okay? So what that looks like is you have a research poll found that 35% of Americans got their most recent news from social media. The survey asked about 2,078 adults in the U.S. questions about their media consumption. 95% confidence was given for the conclusions of the poll. Now, this just means the 95% confident is just based on the statement, okay? We are only going to do that in our class. When you get to other stat courses, that confidence interval can change. We are just strictly sticking to 95%. Does it have anything to do with our final statement? No. That just means we're almost accurate that this is what the results would be, whatever we're measuring. So what is the population? All Americans, and we're going to classify all American adults. What's our statistic? 35%. And the reason that is a statistic and not a parameter is because a poll and a survey was done, and that's what they found. Okay? What is the sample size? Okay. So now, when we find the margin of error, remember it's 1 over the square root of n, n being your sample size. Okay? So it's 1 over square root of 2078. Okay? So we're going to write it as a decimal. 3 places after the decimal, please. Okay, so 1 divided by the square root of 2078. That sample, that margin of error formula is standard. It's not. Okay, that's as a decimal. What is our percent? Yep. 2.2%. 2. We are taking the square root, and it's creating an interval. So 1 divided by the square root of 2078. Yep. Okay. So now the confidence interval. Anytime it asks for this, it's your estimate or your statistic plus or minus your margin of error. Okay, so confidence interval, statistic, plus or minus your margin of error. That is your interval. It's really not that bad if we just stop talking and pay attention. Yeah. Wait, no, we're there. We're not there yet. Okay? So the confidence interval is our statistic plus or minus our margin of error. Okay? In conclusion, when we get to the statement, Jason also just brought it up. We are 95% confident that the percent of Americans getting their news from social media is between what? What is the actual percentages it's between? Yep. 37.2, but what's the first one? 32.8. So 32.8%. Because what does this mean, you guys? What does this mean? How do we get to those numbers? I know Alina and Jason, you got this right now. Yellow. Yeah, so what does that mean? How did I get to 32.8? 35 minus 2.2, 35 plus 2.2. Okay, so the confidence interval is your statistic, whatever is given to you, okay, then plus or minus your margin of error. So they give you this range to make up for any errors that might occur. It's a buffer. If we had a single percentage, that means it's definitely 35%, which is unheard of. You can't have a definite percent. Yeah. It's always given to us. Yep. 95% confident. Nope. Yep. Always 95%. And this has nothing to do with our interval, okay? It means that we're almost certain it would be between those, okay? So we're going to skip around due to, actually, we're right, okay. A survey reported 16.8% of the population smoked with a margin of error of 3.2%. So what is the actual range? So what do we have to set up in order to get to a range, Coop? Perfect. So 16.8% plus or minus 3.2. That's what you have to do in order to find the range, which is what? Yeah. Perfect. 13.6% to 20%. Okay. So what are some reasons why we have a range of values and not just a single percent? Can't be definite. Good. Yeah, Jason. Correct. Cool. Has to be between two numbers, because if we had definite, that would mean we are 100% certain that 60% of the 16.8% of the population smoked. Okay, if we had one percentage. So instead we give a range, because again, it's only a sample. That's all we're looking at. Okay, so number 3, this is working backwards. They're giving you the confidence statement. Okay, so we have to find the estimate, the margin of error, and the interval. So we're working backwards. Okay, so they're saying a student gets a printout of PSAT diagnostic. Let's say that they're 95% confident that she will score between 540 and 600 on the reading and writing sections. What is the estimate? So what is our statistic? What would be, we're working backwards, yeah. Which is? What would it be? Liv? Careful. That's the difference between the two, right? So the estimate has to be our statistic. So what is middle of the road? What's the score that's middle of the road? 570. Okay, we get that by, Liv pointed it out correctly in Coop 2, the difference was 60, right? So in order to find that, you take the two intervals and take the average. You take the two parts of the range and take the average, which we end up getting 570. So what is the margin of error though? And it won't be a percent in this case, yeah. 30. So what we just did is we're working backwards. In the previous two examples, we were given both of these. Okay? So the interval will then be 570 plus or minus 30. Okay? So what we just did here is just work backwards. That's all we did. We worked backwards. Okay? All right, and the last one for today. Another poll broke up participants into two groups and asked both if they were bothered by seeing other people not recycle. Group A had a sample size of 438 people that were surveyed. Group B had 191. If 61% of both groups answered yes, they were bothered. So 61% means Group A, that's their statistic, and Group B, that's their statistic. So what are we missing in order to figure out the confidence interval? The margin of error. So how would I find Group A? What is N for Group A? 438. So 1 over the square root of 438. What do we get? Should get 0.048 when you round. Okay. 0.048, which is 4.8%. So, how would I write my interval? Remember, it's my statistic plus or minus my margin of error. Alina? Good. Okay, so that's where we start. Now, if we use group A, we are 95% confident the true proportion of Americans would be bothered by seeing other people not recycle is between what two numbers? Too much. Perfect. Okay, and again, we get that by 61 minus the 4.8 and 61 plus the 4.8. Okay, make sense? Try group B. Go ahead. What is my confidence interval for group B? Josh? Good. Okay, how many of you did get the 7.2? Good. It was 1 over the square root of 191. Okay, therefore, using group B, we are 95% confident the true proportion of Americans would be bothered by seeing other people not recycle is between what? Well, good. Okay, so which group is more useful and why? Lena? Okay, yeah. Okay, is that a good thing though? Correct. So it would be group A because our goal is we have a larger sample size and this interval is close to our statistic. That's what we want. Okay? And look at the difference. Which one had a larger sample size? A, and our margin of error is smaller, which the interval is smaller. That's what we want. We don't want this large range, okay? Because a lot of errors can occur there, all right? So group A is the most useful for the larger sample size, okay, and the smaller range, all right? So your homework, 4.3 practice, all, it's pages 10 through 12 in your packets. Now, you will realize in the pink packet, okay, you will realize when you get to the practice, number 9 and 11 are the same, so just do one. You don't have to do both, obviously. It's the same exact question, all right? So, there's only, I think, 12 questions too.